So in this video, we're going to do volume by washers for rotation about the y-axis. The video preceded this, we went about the x-axis. Your book does not specify a formula, but it's very similar to the other washer formula. We would just use C and D. And the C and D represent bounds on our y-axis, vertical bounds as opposed to horizontal. Then we have times pi. We have r being some function of y, so capital R squared minus little r of y squared dy. So however we start this problem, we may be given y equals 2x plus 3. Well, that would need to be converted. We would subtract 3 and divide by 2. And we could say x equals y minus 3 divided by 2. So keeping in mind, both of these functions mean the same thing. We've just switched the way we are perceiving them. So when we want to do the washer method about the y-axis, we need x in terms of y. So here I've brought in an image. We are going to rotate this curve, x equals tangent y, about the y-axis. So we're going to find this volume if I take that and rotate it about the y-axis. So that would give me a cross-section that looks roughly like this. It is going to end up being cylindrical in shape. Okay, with this kind of cut out cone in the center. And one thing you'll notice, my function here, x, is already in terms of y, so that's helpful for us. When we start to think about our radius, we always measure that radius out perpendicular from the axis of rotation. So in this case, if I needed to find my radius, I would be going out in this direction, perpendicular or horizontally from the y-axis. Okay? So the only difference, remember before we did above minus below, in this case, when we're doing this, this is always going to be our right radius minus the left. It's always going to be the one further away from the axis minus the inner. Outer minus inner, right minus left. Okay, so if we were to set this up, we would say volume equals the integral. My horizontal bounds are going to be from 0 and pi over 4. I'm going to put my pi in there. My outer radius is going to be 1, and we have that quantity squared, minus my inner radius is tangent y. And that quantity also needs to be squared. So that's our setup. Pause the video, make sure you understand how I set this up. It can be a little confusing, but the more practice you get with it, the easier it is to visualize. All right, so again, if you're using the washer method and you're going about the x-axis, or some horizontal line, it's always going to be in terms of x. And if we're going about the y-axis, we have x in terms of y. All right, so let's work this problem out. I'm going to scroll up here now that we've set it up. And this would be equal to pi, the integral from 0 to pi over 4 of 1 minus tangent squared y dy. Now in order for me to simplify this, I'm going to need to use a Pythagorean identity. So a fact here that I know is that tangent squared y would be equal to secant squared y minus 1. And if I plug that in, pi, the integral from 0 to pi over 4, 1 minus secant squared y minus 1 dy. 0 to pi over 4. 1 minus negative 1 is 2 minus secant squared y dy. And I wanted to turn that tangent squared into secant squared, of course, because I know the integral of secant squared. The integral of secant squared is tangent. Remember, the derivative of tangent is secant squared. So I have here pi. I'm going to integrate that. That will become 2y minus tangent y. And we need to evaluate that from pi over 4 to 0. So I have pi. I've got 2 times pi over 4 minus the tangent of pi over 4 minus 2 times 0 minus the tangent of 0. And these values here, these are going to simplify. 2 times pi over 4 is pi over 2. Tangent of pi over 4, or 45 degrees, is positive 1. And then we've got minus 0 minus 0. 2 times 0 is 0, and tangent of 0 is 0. So we don't need that there at all. And distributing, we end up with pi squared over 2 minus pi. That represents the volume of this, in a sense, a wide cylinder. And we have kind of a cone cut out of it. Okay, it goes down a little further. All right, so I hope that helps. You know, and the only way to get better at this is to practice. So get plugging away.